So, my name is Nick Wolff, and
my name is Thomas Gray.
And we'll be performing experiment 1.5. In this experiment, we'll be performing a single displacement reaction with zinc and hydrochloric acid. Now, since this is a closed reaction, seeing as it creates a hydrogen gas, we'll be needing an Erlenmeyer flask so that it can close the system. Now, first we're going to add in the 6 molar solution of hydrochloric acid. We're going to add in 15 milliliters of this solution and wait for it to fill up the flask. And now we're going to close this system. So before we add in the zinc,
next we're going to put in a pressure gauge and a temperature gauge so we can use it to observe the reaction more easily. So the pressure gauge will be set to atmospheres right now, and our temperature gauge is in Celsius, showing room temperature. And now we will add the zinc, 5 grams of zinc, or 0.25.
We're going to add in 0.25 grams of zinc so that it doesn't accidentally blow up the container.
Yes. As you can see, it immediately begins to react in bubbles. The pressure rises, as does the temperature, so this reaction is producing heat, as well as producing some kind of gas, hydrogen gas, as you mentioned earlier.
Now, as this is cooling down, since the reaction is complete, we're going to tab over to the equation. Now, this equation, as you can see, is 1 mole of zinc for every 2 moles of hydrochloric acid. Now, the zinc is a solid and the hydrochloric acid is an aqueous solution. When they're put together, they react in a single displacement reaction to form zinc chloride, which is an aqueous solution. This actually dissociates in water, and H2 gas, which is hydrogen gas. Now, as we're still waiting for it to cool down within half a degree of room temperature, we're going to do something else.
Yeah, so earlier I slipped up and accidentally said 5 grams of zinc, which is a little bit too much. So what we're going to do now is we're going to do 25 grams of zinc as soon as he closes that flask.
Because a difference of times 100 is
only a small gap.
Definitely not going to make a difference. This should be instantaneous.
Oops.
That's why we do this online and not in the lab itself.
Glass is cheap. Alright, so we are still waiting on that to cool.
This is the best part. We gotta wait.
Well, yeah. Again, we are waiting this to reach within half a degree of room temperature, so when this reaches 22, we should be good. Now you'll note that the pressure has still remained high, as the gas is permanently created and has not had, it's not been dissolved or anything.
And there we go. We are now within half degree of room temperature. So let's get rid of these instruments, and we'll do exactly what we do in real life. We'll throw them in the trash.
Because they're cheap. Totally.
So we want to see how much hydrogen gas we form. So we're going to put in a gas syringe into this and see how much gas is pushed into this. So it looks like we formed 92.5 milliliters of hydrogen gas. The rest of the gas is the air left over from the original. And we also have this zinc chloride solution down here. So let's end this off by adding the amount of zinc that we wanted to have before. Add in our 25 grams. Oh look, it blew off the top.
And that's all.